Video, and in this video we are going to be talking about how you can build your first smart contract and deploy it to Ethereum network so that anyone can go ahead and test a contract and try to interact with a contract. So in this video we will cover everything about how you can deploy a contract, how you can write a contract, and eventually make it out so that people can able to use it and just try to interact with it. Cool. So first thing first, if you open up your any browser, let's say I have my Firefox over here, and make sure that you have MetaMask installed. This is basically a wallet which you are going to be using to send a transaction in between, and make sure that you have. If you don't have installed this, I had a video on this, so you can just watch that video. I will link that video in the description and just view that video, how you can install that and all kind of stuff. Then we are going to be building a smart contract that is written in Solidity. So eventually this language is the main language which we are using to write a contract on Ethereum network or any other network which are built on Ethereum. Now first thing first, just open up a terminal so we can start coding. First thing, just open up terminal, and let me just make it the size big so you can able to view it. Cool. So now we can be making a new directory. So let's say we are in just home. Let's say cd into desktop, and just make a new folder. Let's say contract. cd into this contract, and just open up with code. Once you open that with any of the Visual Studio Code, any of the code editor, make sure that you have let's say so we are going to be making our first contract. Let's say make a new file, contract.sol. Cool. So now let's make a contract. So we're going to be making the simplest contract today. It should be a simple counter contract where people can able to listen to the contract, listen to the count. They can increment the contract, they can increment the count, and they can also decrease the contract count by 1. Cool. So the very beginning you should have a comment at the top of your file. Let's say we are going to be using SPDX license identifier, which is MID. This is necessary when you are deploying a contract on open source. Every time when you deploy the contract on maybe since the blockchain is visible and you can just view the code online, you should have this above, I would say, a certain comment. This signifies that your contract is eventually identified by a certain license, so that people can able to it just decreases the chances of copyright if you have a certain complex contract, and you want to avoid people to copy a contract. You can just use this. And if you not want to deploy a contract, you can just, instead of this license identifier, you can just use unlicensed over here. Cool. So now once we write the comment, you should be, then the next thing which we are going to be using is we need to specify the version of the file which we're going to be working on. Let's say we need to start with the pragma solidity, and just add a our code and just use 0.8.7. Cool. So now we specifying that this is the current version of the contract which we will be using. This power sign indicates that we are okay to use if this 0.8.7 is just changed to 0.1, 0.2, 0.3 or 0.14, right? This is the main word, this is the main keyword, because there is a lot of outbreaking change happening in the version of this compiler. That's why anyone to whom you talk to, they always tell you to use this quotation mark. Cool. Now the second thing which we're going to be using to make our contract, let's say make a contract keyword. These are the keywords. This is the keyword in the contract. Let's say we have a contract of, let's say make it a counter contract, and we have this contract of counter, and we want to make a uint of 256 and just make it public, and just make it like count. We are declaring a non-negative integers of name count, right? We can also say, we can also write this in this manner. Let's say 0. This count is equals to 0. This also the same as writing this, right? Because initial value of this UN256 is always initialized to 0. That's why we are okay to use this without writing equal to 0. Cool. So now let's make a function. Let's make a function to, let's say, get the count, and let's say just make a function of get count, and we are going to be making it as a public function of view, and going to be returns. It's going to be returning UN256, and then we are going to be returning our simple count. Cool. So what it does, this count returns the value of the count, the current count which we have. So every time a person runs this function get count, it will just simply returns this value of get count of the current count which we have right now. Let's say this is a basic function, and yeah. So now after that we can make another function to increment the count value. Cool. So let's make a function. Let's say increment, and let's make it a public function, and let's say count is equals to count plus 1. Let's say plus 1. Cool. So this increment function add another count in your certain count variable. Let's say first, let's say over here we have a count initialized to 0. When a user runs this function, it just add a 1 count to this. Now this count is equal to 1. Now this is a simple function. Now let's make another function of, let's make a function of, let's say, decrement, and let's make it a public function, and let's say count is equals to count minus 1. Yeah. So this is essentially a function to decrement the count value. Cool. So we have this increment function and decrement function. So we almost done with the contract. This is the simplest contract which we have ever made, and now it's a time to deploy the contract on Ethereum. So you can use a IDE. So I can even compile this code on my main on my PC, but sometimes if I just deploy the contract, it's not that interactive, right? So even I can just say, let's say if you have a Solc installed, let's say Solc is a compiler which is so you can eventually just search for Solc Solidity, let's say Solc compiler install. You can just install the compiler from here. Yeah, it's the simplest compiler which is installed by npm npm by install globally, and yeah, cool. So every time we install, let's say if you install a Solc, you can let's say Solc version, you will see the current compiler is almost like 0.8.14 plus, right? So yeah, we can run this file. Now you may have aware of, every time we run our Solidity file, it compiles into bytecode, and it just goes to EVM. It just talks to EVM. in two languages, in just two components. We can say the first component would be the bytecode, and the second one is going to be the ABI. The bytecode is essentially in hexadecimals. It is long strings. Let's say I just show you. Let's say we have the Sol C. Let's make another comment so you can understand it more clearly. So we have our contract converted to bytecode and ABI. Then it goes to EVM. Yeah. So if I just run Sol C and just add your file, let's say my file name is contract.sol, and let's say bin stands for the binary which we have. So once I, let's say, press enter, you will see this is the binary. These are the long string which are just the hexadecimals of a current contract. These are the binary code which then goes to EVM, and then it just then it just shows the output by using ABI and your binary code. Let's say this is the binary one, and we also have, let's say, Sol C, and let's say we have our ABI. This is an ABI, and you may be aware of ABI is a set of instructions that when ABI and binary bytecode give combined, it just gets given instructions to the EVM that these are the files which code is going to be have, and this is always in JSON format. So let's say we have inputs which is a name and count, which is output of this internal type of this. Let's say these all are in a JSON format. Let's say let's make it more interactive by copying the same code and using it on Remix. So Remix is essentially an IDE which is provided by Ethereum itself for developers who want to test their code, who want to write their code, who want to compile their code, and all sort of stuff. Let's say you can just go on to remix.ethereum.org. This is the main website for any other Ethereum IDE development if you can use it. So once you open the website, yeah, so the website looks something like this. So make sure that you install, let's say we have a workspace of Ethereum project demo, and you can just make a new workspace. Let's say just click on this workspace, and let's make a workspace of contract, first contract, and okay, and just make it like blank, or let's make it a default. Let's say we have a contract demo, and just click on this OK. It will then create a lot of workspaces for us, so we don't need to worry about this test script and all sort of files. We only need to worry about this contract folder. Now just delete everything. Let's now just delete everything, so we can start with the very beginning. Let's delete everything from here, even the contract one. Let's delete it, and let's delete everything for now, from the script folder to your test folder. These are the folder which is used while testing, if you want to test your contract on this Remix itself. So just make a folder that is contract, and inside this contracts, let's make a file of dap.sol. Now the code which you copied from here, just paste that code over here, and once you paste this code over here, let's say, yeah, it looked a bit like this. The same code which we have written over here, and we copied it right here. Now let's say just open up this over here. So there's a third icon in the sidebar, this named as the compiler which we will be using. So the current compiler which we have over here is 0.8.7. So just it just automatically detected your compiler for your file. You don't need to worry about that. And then just click on this compile button, and now it's compiled. And again you will see there's a two sections over here. There's a bytecode and there's an ABI. So previously, if I compile on my desktop, you will see the binary code looks a bit like this, right, and the ABI looks a bit like this, right. So if I compile this, if I just copy this code from here and just show you over here, let's say make a bytecode.txt and paste it over here. This is essentially the ABI. I just copy the ABI. So this is the ABI, and the ABI is looking the same as which we have right over here, right. So ABI is essentially a set of instructions which are written to the contract, which then the EVM understand, and then they just basically execute the code. So this essentially written in JSON format. We have our input, we have our name, output, etc. And just it's basically the same. If you just copy the bytecode, it's almost look kind of same. Just copy the bytecode and you will see the bytecode. Now over here the bytecode is encoded in your object, right. This is an object. We also have this function which is empty for now, so you don't need to worry about this function, debug data, this link references and map source. Just look at this. This is our bytecode, and this is referenced by this object keyword, right. So that's all about this. Let's move on over here. Now since we have compile a contract, we also test it. We don't test it yet, but we just tell you about the bytecode and the ABI, and we also compile the contract. Now it's the time to deploy the contract. Now over here you will see there are a lot of things going on over here. First, if we go this if we just click on this I would say deploy and run transactions, you will see there's this function, there's a section of environment, right. And this environment consists of this JavaScript virtual machine and JavaScript virtual machine of Berlin, right. So this essentially means these are the two private blockchains. And so if I just click on this JavaScript virtual machine, this is essentially a private blockchain that is essentially not controlled, it's just sitting in a certain place like London, and this have this random accounts, right. So they have this random accounts of maybe like 10, and every account consists of 100 ethers. These are obviously the fake ethers, it's not the real ethers, but every time when you run the contract, and if you want to just make that transaction much more faster than anybody else, you can use this virtual machines to just test out a contract. And just for now we are going to be using this injected web3. So injected web3 is essentially so when you click on this injected web3, just open up your MetaMask. This essentially means you need to inject your web3. So we have this web3 browser which we have right now, which is MetaMask. So we want to integrate it into our this deploy and run transaction environment variable. So you can just add your password and just click on this unlock. So once you unlock your account, it will add it over here, right. So we have this account, and you can use a chain, which is essentially we are going to be using Rinkeby today. So Rinkeby, just move on to Rinkeby. So Rinkeby is essentially a testnet for Ethereum network. So it's just the same. If you want to deploy a contract on Ethereum mainnet, you can just select your Ethereum mainnet from this networks tab, and you can just deploy from here. I don't have much money right for now, and don't want to deploy, I don't want to waste my money on this, so I can just using your Rinkeby testnet for now. But it's just the same. If you want to deploy on this, you can just choose that, and it's just work the same. And I also have very less ether right now, right. So you can use any of the faucets. So right now we have a lot of faucets. to get the test ethers. Test ethers are essentially the ether which you can use to just test out your transaction. Is it working on the certain machine or not? So let's say you can use test ring b, let's say ring b faucets. You will see the famous faucet over here. So I recommend to use faucet.chainlink.inc. So this is essentially the best faucet. You can just use it for now. It is fast and it is also reliable. It is maintained by Chainlink organization. You can just use it. So just select your wallet account and just select the Ringkey testnet, and you are just good to go. We only want the test ether as for now. We don't want link. So let's say request the transaction. It's just initiated to this hash number, and once that done, you can easily use in our Ringkey testnet. Yeah, now it's completed. So now we can use. Now we'll check. Now if you'll see your wallet, it's updated. It just updated to 0.1 and this ETH. Cool. So now what we can do, we have this gas limit. We also have this way. This is just a unit for how we measure gas. So you don't need to worry about this from now. Just for now. And now just click on this deploy. So let me just make this terminal a bit bigger. So just click on this deploy. It's initiated this progress, and you will see this pop-up will open, and it will ask you to pay some sort of gas fee, and just click on this gas fee and confirm. You can also view on this Etherscan, Ringkey Etherscan. So this is our state. It's still pending. So let's say you will see another alert that says this transaction has been completed. Once the transaction has been completed, now it's confirmed. So cool. Now it's confirmed, and you will see this this window will pop up. This is essentially the output. It generated the API and the bytecode, and that give us this this good looking deployed contract, this thing, right? So let's just make it small. So yeah, we have this thing. So over here you will see we have this count. The count is set to go over here. Then this function that's same just to get the count, and if I can just click on this count button, it's initialized to 0 because we don't have any value. I already said that if this value is initialized to this, it's just mean this count is equal to 0. Then if I click on this get count, it's just also 0 because it's just running the count value, and this just initialized to 0. It's also a 0. Then if I click on this increment, you will see the count is increased by 1. Let's say if I click on this increment, it will ask you to pay some sort of gas fee. So let's say confirm, and you will see it increased to 1. Yeah, it's confirmed, and you will see now it's increased to 1. Now we want to make the contract bit more usable. So for that we want to deploy. So if we just click on this link, and now this is the link at which we deploy the contract, right? This is our account, and this is the address for the contract. So we click on this contract, you will see we have two methods which are just called right now. First, the creation of the contract, then we have this right now which we just use to get the increment value for a contract. Let's say over here we want to make the contract verify and publish. Let's say we want to verify a contract. So for that you need to publish the source code for the contract. Let's say I just show you how you can do that. So if you click on this verify and publish, it will open up this pop-up. Now you have to select your compiler. So we have a single page file. So since after that just open up a compiler version. So we are going to be using 0.8.7, which we have over here. let's say 0.8.7, and we are using MIT license. Cool. So just click on this continue now. This window will pop up. It will ask you to enter your source code. So just copy this code and paste this over here, and just you don't need to fill this details of ABI encoder. It's not needed right now. Just click on this I'm not a robot. Just verify and publish. It's taking a bit time. Amazing. Now it's done. Now if we go to a contract, let's say we have this contract right now, you will see now it's published. Now it's check to, you will see this check mark over here. This means now the source code for this contract is verified. Now we can easily write and read a contract from here. Let's say this is our source code, and this is our contract by which we can read the contract, and we can also write the contract. Cool. So now if you click on this count, it just initialized to 0, as we all know. It's set to 1 because I initiated the request over here of increment that set the count, the value of the count equal to 0, equal to 1. That's why it's set to 1 right now. But if we don't do that, it is initially set to 0, and this will also show us 1 because this both are same functions. Now if you click on this write contract, you can also write the contract right now. Let's say you just click on this connect to Web3 and just connect to your wallet. Let's say we are connecting our Etherscan. It's asking for some sort of warning. No, just click on OK. Now it will open up a pop-up, and then you need to confirm the sign in signature, and then it will just connect to this site. Since after that done, you can use this increment value. The increment function states it just add 1 to a certain value. Let's say if I just click on this increment, it will open a pop-up. Here we go, and this pop-up is essentially ask you to pay a gas. Let's say I want to increase the gas so that the transaction would just initiate so fast. Let's say just select to the high, save, and just confirm it. Once that confirmed, you can also view your transaction hash over here. You will see it's pending. Yeah, it's pending. Now it's confirmed. Now once that confirmed, you will see just click on this read contract and refresh the page. You will see it's turned back to, now it's turned back to 2. Let's say now it's turned back to 2 because we increment the count by 1. Now it's 1 plus 1 it equals to 2. That's why it's turned to 2. Now you can also decrease the value for a count. Let's say click on this decrement, just write the contract. When to connect to Web3, let's connect to Web3. Enter your Web3, decrement the count. It will open this pop-up, and you will then easily now it's initiate the transaction over here. You will see it will now decrease 1 value from the current value of count, which we have 2. So 2 minus 1 is equals to 1. So that's why now the count is set to, now it's success. Now it's confirmed. So we'll go, now it's confirmed. Now we just click on this transaction and just read contract and just refresh this page. You will see this now change back to 1. Cool. So now contract is working absolutely fine. This is the first video in which I just deploy the contract. In the next video I will just show you some sort of advanced concept which you can do from this contract. You can just initiate this contract to your main website and let people to just use from this from your website itself. Cool. So that's all for this video. Thank you.